Hi everyone. Just gonna wait a couple of minutes as we do. The setup from Ben's video from last week, I've changed it a little bit, so here you have a much closer view of the action. So before it was much higher, it was harder to see, but also you got to see Ben's head from the top, and that's just only mildly interesting. If you're on Slack, on the Boldport Club Slack, go to Variety Show channel, and there I'll be seeing your messages every now and then. And we'll discuss. Otherwise, I don't see messages appearing elsewhere during the program. All right. Well. Okay. So before I'm gonna build BINCO, which is project number 19 of the Boldport Club, November's project. So most of the people already got it, and some of the people have built it, and so I'm going to show how I would build it. Normally I don't try to prescribe how to build something. Everyone has their own way to do and their own techniques, and it's nice when things just appear and being built differently. So if you've been with the club for a while, you'd see that the style of notes and instructions is very kind of loose for practical reasons, but also because I'd like people to discover things on their own. Okay. All right, so somebody told me that you're hearing me. That's good. So before I start, I want to just discuss quickly some things that happen here at Boldport that normally a lot of people, or I imagine most people, wouldn't care. So this is the PCB. The prototype and the production version, and if you look at it, they're almost the same, but they're quite different in their appearance. This one is much more matte, this is more shiny, and the solder mask is transparent. You can see the digits in the background, sort of as it's a copper pour, but of digits that isn't connected to anything. But the way I define it is a copper pour, and this is quite different. And these were both manufactured by Eurocircuits, but in their different fabs. So this is the prototype, and this is the production. And most people wouldn't necessarily care, but this is something that I pay attention to when I receive things. In this case, I didn't care either way, but in some cases I would care that the prototype didn't look exactly like the production. So look like, functionally, there has been fixes, couple of fixes and one enhancement between the prototype and the production. But normally I would expect them to look exactly the same. This is one of the reasons why I'm working with one or two fabs that are very consistent. But I'm already expecting this, and when it is an issue, I can flag it up, and make sure that it's manufactured in the same way. But these sort of things happen, and it matters. For me, at least here. Okay, so I'll leave the prototype aside. This is the instructions sheet that I prepared, and I'll show it to you in color. So you can get to the website. It's boldport.com/BINCO, BINCO, and this is the page, and this is the schematic and the instructions and the sort of diagram of the board. So if you're tired looking at me, you can go look at the schematic as I go through it. All right, so quickly about the circuit. So we have a 555, which is a timer IC, integrated circuit, set up in astable mode, which just means that it's set up as a free running clock. That means that you set it up a particular way, and there is a clock signal of a particular frequency and a particular duty cycle coming out of the output pin. Then that goes into a 14-bit counter, of which the first bit, so the least significant bit, is brought out but normally ignored. So you see it's just not connected to anything. And then the most significant 11 bits are brought out. This is here a master reset, and that's in broad strokes what's going on here. So the output of the 555 is driving the counter enable, which is active low, designated by this bar, so CP bar. Every time this goes low, this counts once. So let's build the thing, and then we can go through what is happening here, because then, and here, then we could see what, see the effect and see why it's happening. And on top of that, it's not a trivial, I mean, it is trivial, but it's not immediately obvious what's going on here with the power. And the reason is laid out that way is for power savings, because it's meant to work for a very long time on a small battery. Now, the first thing we'll have to decide is whether we want to go. It's also this is how the kit comes. This is called a pillowcase. Anyway, what I wanted to show you is the kit can count up or down. You have to decide that when you're building the kit, because the way you would orient the LEDs matter, and there's this jumper here that needs to be set up correctly. So we need to decide that. I'm going to build this one as a count up. You just check if there are any messages. No. Okay. So let's open this thing. This is a PCB. There's a sheet of tape. We'll leave that for later. And the components. So I usually will use a container. Oh yeah, before I begin and before I forget, normally this is a setup for filming, and normally downstairs where we have our station, we would have ESD wristbands and an extractor for the soldering fumes, but it would really reduce the quality of the video if I use them here. So just for the purpose of filming this, I'm not earthed, and I'm not using a filter. So, oh yeah, I'll use this container because it'll reduce the chances of things flying out and getting lost. This is a new tweezers. I couldn't find my other two, so I found this one. So we have resistors, capacitors, more resistors, the 555 and the counter, and the 3 buttons. So these buttons were donated by Snaptron. It's an American company, and they're very nice. And they came here and we discussed, and I discussed their products, and I've had ideas about what to do with them, and they've donated it for the project. So it's these guys, Snaptron. They have a very comprehensive, I suppose the best, wait, hold on, okay. They have the best sample kit that I've ever seen, really. It's very, you get a lot of samples, and it's really a really complete kind of kit. So I think anyone can ask for it on their website and get it. Okay, so I will put the big components aside, and well, so this is our board. Need to decide which side to do first. I'm going to do the LEDs and resistors first. So as I indicated before, I've decided that we're going to build it counting up. So that means that the LED needs to go, the cathode needs to be on this side. So that's important to get right. So what I'll do, well, I'll empty these, and what I'll normally do is empty the components inside of a box. Now, firstly, there's you have the box, so it has fewer places to run to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, that's what we're expecting. But the other thing is you can sort of tap on it to. In this case, I mean, with resistors, it works better. But anyway, you can flip them, and it'll be easier to handle. Here, we can see sort of a pixelated triangle, and that corresponds to sort of the symbol of the LED. Of the triangle, so we know that the cathode is on this end right here. So what's nice about this, these are LEDs that are, they go through the board. So we have the holes here, and we just need to, well, it doesn't work that well with these LEDs, but so we can just lay them in like that. The other thing I wanted to show you as a way to advertise other Boldport Club kits is the Ligum Dio LED tester, and it's helpful if you need to test LEDs before you use them. So this little mirror can test SMD LEDs between this half and this half. So you put it here, and there's, I think it's set to have 20 milliamps constant current. So this one works. I've never had a failure of these LEDs, but anyway, this is the Ligum Dio constant current driver here. Very nice little circuit, and these quadrants are configurable, but enough of that. Okay, let's put the rest of them in. See what happened there? You didn't see it. Yeah, the white background of this box is throwing off the white balancing. So I'll just keep it out of shot. But what happened was a classic flick of the tweezers. But the boundary of the box saved it from the carpet gods. It helps to be patient with soldering, but also well fed. Soldering on an empty stomach, that's a challenge, because your hands will end up shaking. Your hands will end up shaking. You'll become a bit anxious, and, well, not anxious, but just wanting to get it over with, and it's not helpful. Then you end up soldering things on the wrong side, and so on. On the other hand, you do want to get it over because you're dying to know if the thing works. Particularly if you're bringing up a prototype or something like that. So sometimes when it's a complex prototype or something that I know will take me quite a while, I'll plan ahead and think, how can I build this so I get an intermediate result, so I can put in power and know that it's working, or at least partially working, and then I know that, you know, the rest could be just fun soldering. Okay, so they're all lined up nicely here, and we've done them correctly. Let me just verify. Oh, yeah. So count up. Okay. LED like that. Alright, good. So now I need to change the tip. So I'm going to use two soldering, two solders. The braids. This is a 0.7 millimeter, and this is a 0.3 millimeter. I found that for SMD work, that also has some other non-fine pitch stuff. These these two work very well. Okay. So what I normally do, these will invariably shift out of position, but I use the fingers a lot to hold things together. I don't use those helping hands that, you know, I don't find that helpful. And so I'll use the fingers to hold things in place. So I'm anchoring my left hand with the fingers, and I'm also pressing on the board to hold it in place. And now I can come in and solder the component in. Now I'll put a little bit of solder, let it flow, and then move it out. And then with the heat, as it's heated, I will adjust it into place. So this one, lift it slightly. So I'll just press it down. It's actually quite good to do. Okay. These look pretty nicely aligned. I'm just going to make sure that they're flush. So you press, heat up, release, let it cool a little bit, and then release the whatever you're using to press it. Okay, so that's done. Now let's do the resistors. need 11, 3, 4, 5, 7. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11. Okay. About an equal distribution of top and bottom, which is pretty much the best you can ask for. All right, so let's do this. Right, so every person will have a different technique on how to do these sort of how to do surface mount in particular. There's no real right way. I tend not to use flux unless I really have to, and this is how I normally do surface mount components. I will put solder, a little bit of solder on the pads, on one of the pads. And then, like before, put that also breathing. I know I find myself breathing in a particular pattern when I solder. I don't know if other people pay attention to that. Again, I'm positioning it in place, and then I'm making sure that it's flush with the board. So position, press, so while you have only one pad connected, you can adjust. So now I have all of these. Oh no, most of them, and then I can do this and get some more to flip. Good. See? The thing about tweezers as well is that I tend to sometimes press too hard, and when you press too hard, the component just flicks out. Normally that means that you're not finding it. And when you're soldering a kit like that, if a component is gone missing, you're out a component, and then you have to figure out how to get one, but if you contact me, normally I have spares and I'll ship it to you. I think I spoke with somebody that soldered for the first time, and she was surprised on how fast the solder cools down. And you know, once you're used to it, you don't think about it, but I think maybe when I think it's a natural thing to think that it'll take it quite a while, but it's nearly instantaneous in most cases. Okay, so we have the one side. Come on, focus. We have one side of the LEDs and resistors soldered and flush with the board. So now we do the other side in one go, kind of thing. I think beginners also tend to put more solder than necessary. I certainly did. I think putting more solder than necessary in this case wouldn't make a whole lot of difference. It just wouldn't look too good. Okay, so that's, you know, they're not all at the angle that I would prefer, but it's good enough. Right, so we did talk about this jumper. Actually, before that, let's do the other components. So we have a FET here. So I'm gonna put it on the right side. Come on. Okay. And here again, I'll put solder on one of the pads, just a little bit. Stabilize the board by pressing on it with my finger. align it. Okay. The other thing I think beginners don't do as well is let the solder flow. And it's just a touch, and sometimes it's you kind of see it when you get used to it. You see when the solder has flown. Okay, that's good. Now let's see the schematic. This is R101. It's been a while since I've built these, because once it's with club members, it's been a while. Because the cycle starts quite a few months before. Anyway, R101. That's 1.5K, which is another one of these. There we go. All right, so now the jumper. So we're counting up, so we should jump the left side. Just fine. This one is already built, you know. I don't want to touch this. Yeah. Okay, so I'm going with the larger braid, and there we are. Jumped. So this side is done except for the battery. Now the battery I'm not going to put in until the end, because then that'll interfere with soldering this side, because it won't be sitting relatively flush with the table. That's another thing. It's worth planning, because this is probably the easiest component to solder. But if you solder it first, so it'll be constantly in your way. Right. So that's done. This part is optional if you wanted to connect an external power supply only when the battery isn't connected, of course, because these are shorted. But yeah, maybe I've used that in order to measure the current and so on. Okay, top side. Let's do the ICs. Okay. I'll do the smaller 555 first. Since I'm not earthed, try not to touch it. This is an anti-static tweezers, and I'll just take it out and put it on the board. So I normally treat the board as sort of a canvas. This is where I sort of stage things. Right. So we see the pin number 1 indicator here, and on this chip we actually have a line Yeah, this is not going to focus. Yeah, so you see the line. The line corresponds to pin number 1. So you see, instead of rotating the chip, I just rotate the board. It's easier. And now I put it here at the orientation that I want it. As before, I'll put a little bit of solder on one of the pads. So I melt the solder and move it to the edge of the pad, and that allows me to just place and play around with the position of the IC. So now that's in place. Of course, it can still move. Be gentle with it, and I'll normally do the opposite side. Again, it's very gently because it can still move. Then go back and do the other corner. The other one. And then the rest, just one by one. So put it against the pin and the pad. And just let it reflow. Yep. That looks good. Yeah. See, it's a little bit of an exposed copper here. That's it's from scratching. Scratching with the iron. It happens. Alright, that looks fine. I mean, this is not a terribly fine pitch component. You can easily by eye see that there aren't any shorts. The main thing that could happen here is sort of a cold joint where it looks like the pin is connected to the board, but it actually isn't. But I think this looks fine. Now, this is the counter wrapped up in anti-static foam. Now, the reason we do this like that is because sometimes we can't get the components to come in a reel like this. This came in a reel, so it's easy for us to just cut as a kit. Just cut it and put it in the kit. Whereas this one came in a tube, and we're obviously not going to ship it like that because the legs are going to be damaged potentially, and so we have to wrap it in this anti-static foam. And we are earthed while we do that, while we handle ICs in general. And that's a solution. It's not very pretty, but I think it works. It's cheap. Often been thinking about a solution to this thing, but I haven't come up with anything good. Right. So again, check for pin number 1. Yeah, we have it here and here. So that's the line up. Move this here. do the same thing. Okay, a little bit of solder. Melt it, go to the edge, position, remove, and remove your tweezers. This isn't perfect, but because I only have one pin soldered, I can nudge this a little bit. Now it's centered. Ish. A little bit of an angle here. Okay, that's good enough. Okay, pad, solder, flow. I'm gonna come back to it. Flow. Okay, so now the rest. You're looking for that concave shape against this gull wing pin. That's kind of, to me, means that in all likelihood it's okay. Just the right amount of solder. Okay. That looks all right. Okay. Just checking. Right. What's next? Next are the other components, of course. Let's do those capacitors first. Just gonna leave that. I'm checking messages when when you see me looking there on our Slack channel. Okay, I know that the only capacitor that I shouldn't be soldering is this one. That's an optional capacitor for the 555. So if you wanted to have it extra stable, you have this. The pad is there, but there's none in the kit. So, and I can see here that the rest are 1 microfarad. So we have a 1 microfarad capacitors, and let's solder them. Okay. The other side. If I don't do the other side somewhere close to when I've done the first side, I'll forget, and then things won't work. So I tend to do it in kind of in small batches. Right, so the next one, the next component is two 47K resistors. And those go onto R011 and 100. First, let's take them out. Okay, so R011 and 100. Okay. There we go. Okay. All right. Now, 3 left. But wait, there's 4. 4. So here's a little story. So, well, there's 4 because I've added a 47K kind of a bit later because it increases the power efficiency of the board. But this was already cut, and so there's an extra 1.5K resistor in here. The funny thing is that sometimes what ends up happening is that people finish the board and they see that there's an extra component, and they think that they've done something wrong. So sometimes, even though I can give extra components, I decide not to because I don't want to cause confusion. So it's an interesting thing. Initially I thought, well, just have extra components. The extra cost of this is nothing. But then I get emails to say, what about this extra one? I think it's great because it means people really paying attention and wanting to do it correctly. So now I will tend to, I think for this one I haven't, but I will tend to write somewhere that there is an extra resistor. I don't want to cause people to be concerned about it. So this is the explanation why there's an extra one here. I love it when people notice something, they get in touch. Firstly, it tells me that they're building the kits, which is great, because I know that people are receiving it, they're not building it, and so on, which is fair enough. But of course, I create them for people to enjoy. So they're building the kits, they're engaged, they're not concerned about emailing me and contacting and saying that, you know, something didn't go well, or there's something extra or something missing. Of course, if something's missing, it's not good, at all. Try to create a very good experience for people, and when something's missing, that tarnishes that experience, and I take it very seriously, and try to minimize that from happening. But it's difficult. It's difficult to do. Okay, so okay, all right, we're done with the soldering. I'll put the battery holder before. Let me change the tip here. So with the battery holder, let me check something. With the battery holder, the battery holder of course goes on like this, and the battery goes on like this inside. Now, depending on the size of this pad and depending on the thickness of the solder mask, you can sometimes, I mean, in this case, there's very little height difference, but sometimes it's quite pronounced. So you want to add a little bit of solder to the pad, very, very thin layer. That's it. So that would increase the height and the chances that this would make a good contact. Right. So the way I do this, I'll align it, and then I'll get something. Actually, the tool that I use isn't here. I'll use a tool to hold it in place, so I don't burn myself. So of course, if I'm heating this part will get heated up. So I'll align it, add some solder, let it flow, align it again, press, keep it for a little bit. No, it's not perfectly. Okay. Now this is still very hot. Don't touch it. But you can solder the other side. Okay. Now, because you've heated, I've heated this. It takes it longer for the solder to cool down. So you do need to hold it a little bit. I don't know if you noticed, but it did jump a little bit. So let it cool. You can see the solder cool down, and this is okay. And I just want to add a little bit more solder on this side. Okay. Burnt flux. Been going for an hour. I'm actually enjoying myself. Right, so now I'm gonna clean it up a little bit. So clean up the board from all the flux. I have an anti-static brush here, and this flux off thing, chemical, and so and a little towel. Sometimes the persistent ones I'd clean up with the tweezers. I'm doing this now because we're going to put labels on top of the board. So firstly, it's good to be clean, but also I don't know what the chemical is going to do to that. You know, I think it's... don't know. Okay. Looks nice and clean. A bit more. Okay. So hopefully we're done with the soldering. Now the buttons. Some people solder the buttons, and you don't do that. You attach it using tape. So that's where this sheet comes in. So the way I've done it is I'll cut a piece that is about the size of the button. Just a bit larger. So cut the corners a little bit, just for style. Just measure it up. It's a bit big. Okay. So we're going to do this one. Where's the third one? I lost it. Oh dear. I lost the reset button. Could it be under? Oh, stuck to my hand. That's terrible. Alright, I'm going to put it here. It was stuck to my hand. Okay. So I take out the backing, or rather peel off the label without touching it, and then I'll just lay it on top of that. So now I have it on the piece of tape, and then align it on the center like that. Press, and that looks good. Hear that lovely click. I love that click. It's weird. I guess that's why those fidget thingies are popular. It's just like that click is something. Anyway. Alright, now this is a magic button. This is a double action button. So you see it has the middle contact and it has the outer two outer contacts, and you can see that the one of the edges is sort of cropped. So I'm going to do the same thing. This button is a bit smaller. Cut the corners a little bit. But for this one, we don't want the adhesive, the tape, to go over this cropped bit, because that might press it against the pad, and that would kind of defeat the purpose. So I crop it accordingly here. So as I did before, get the tape out. Now I'm aligning that cropped bit with the cropped, well, the two cropped bits. And now put it on the board. Yep, that looks fine. You only get one click, but it's to double action. You'll see. I think it's not quite flush, the tape and the thing, but I think it's okay. Just leave it like this. Right, now the last button is the reset button. And small. So again, center, align, good. All right. Come on, focus, focus. Doesn't want to focus. Oh, there we are. That's what it looks like. Okay, so well, let's see if the thing works. Yeah. Okay. The battery is hard to get out, particularly since we put the solder, but it's so I leave it a little bit outside for now. Okay, so press the button, the LEDs come on. This is a slow count and fast count. So that's the double action of this button. Slow and fast. And then when when pressing the on button and you press the reset button, it goes to reset and then count. So obviously this is a binary counter, BINCO, and counting in binary is fun. It's sometimes useful as well. At parties and things like that. But the idea behind this board was that I wanted something to throw in with my stock of boards, and just keep track of it, keep track of inventory. So it should be lasting for a long time. I measured under 100 microamps when it's not on. But low currents is notoriously hard to measure, so it's kind of in the ballpark. I don't have the equipment to be confident about below 100 microamp currents. Okay, so yes, the idea is that you'd have a count, and you leave it for a while, and you come back, you press on it, and you get the same count. So an interesting thing that I allude to in the instructions and when I talk about this board is that there's a particularly interesting sort of anomaly or quirk to this board, and that happens. I'll show you how I trigger it. So if I press on, I'm counting. And then instead of doing what should be the normal thing to do, is to release the count and then release the button, the power button, the on-off button. I do it the other way. So I count and I release this button first. Then I go back and that looks about right, what I've done, what I've had before, and then I'll press again and again. And again, and again, and again, and again, and again. Ooh, it counted. And then I'll press 1, 2, 3, 4, 5, 6, 7, 8, and it counted again. So two questions for the reader, the viewer, who lasted an hour and 15 minutes, is why that happens. Why 8? Firstly, that's the easy part one, and then why does it behave that way when I go through that sequence of releasing the power button or the on-off button while I'm pressing this button? In fact, this will happen even if you press the count button when the power is off. So even if I do it the correct way and then press this, it will happen. See? Okay, now yeah, why does this happen? Okay, so the schematic will help. So what you're seeing here, the frequency and duty cycle. Duty cycle is the amount of high time during a period of the clock, the frequency. So that's how pulse width modulation works, for example. In this case, it doesn't matter. We're only looking for the falling edge in this case. So the duty cycle doesn't play a part. But the duty cycle and frequency are determined by the value of this capacitor, this resistor, and this resistor. So all I'm doing here with this button is a shallow press connects these two, these two together, so that it connects the 47k ohm resistor, and that corresponds to a lower frequency. And then when I'm fully pressing, I'm engaging this 1.5k, which is connected in parallel. Now, Snaptron do not guarantee that either both or one of them is going to be always connected. They say it could be both, could be one. They can't guarantee which state. In this case, it doesn't matter so much because whether I have 1.5k or 1.5k in parallel with 47k is still pretty close to 1.5k, or a value, the value of these two resistors in parallel is not noticeably different than just a 1.5k. So I designed this in such a way that I don't care whether it's just disengaging or both. So that explains the up-down counter. Sorry, the fast and slow counter. Now, this bit here. Well, I'll go. Well, let's cover the power first. You have here V battery. That is always on. I mean, always exists, always present for whatever is connected to it, obviously. Now, this is connected to the on-off button, or the power on, or whatever, the enable button. So when it's pressed, VBAT is shorted to VDD. So VDD is only present when this button is pressed. Okay, so now let's look at that. So in order to maintain state of the counter, I connected VBAT to it, obviously, because it needs to be powered on all the time, otherwise it will lose its state. Now, the 555 is also connected to VBAT, but it's connected to a reset. But it's the reset is connected in such a way that when VDD is not present, it is pulled down to to 0, and it resets because this is active low. The bar indicates that it's active low. So when VDD is on, you have it goes out of reset. When VDD is gone, it's being pulled low to put it in reset. And this 555 has very low current during reset, so under 100 microamps. I think it's in the order of 60 or 50 or 40. I can't remember. So when it's not on, this consumes very little power. Now this one consumes very little power when it's not doing anything, but I have to make sure that the LEDs are off when it's not when there's no power. Now that is where this little bit comes in, because this doesn't lose its state. This is not going into reset. It will have these pins on when it needs to be. If it's counting 1, then Q4, well, not counting 1, counting 8, Q4 will be, sorry, no, 16, 8. It's counting 8, Q4 will be on, be high. That means that if this is connected to ground and VBAT is present, then the LED will be on, and I don't want that. So I've added a switch here that in this case looks, I mean, if you first look at it, it looks silly because you basically have it always on and you have current just going through it. But what it does is that when VDD is gone, then it pulls it low, and that means that there is no path for the LEDs to ground. So they're off. Okay, so that explains that. Of course, when it's counting down, then it's VDD comes from this side, and the LED is oriented opposite what we've done, and therefore this circuitry isn't needed, because if VDD is gone, of course there's no power to power the LEDs. Right. I think I covered it. That's it. We're done. An hour 30 almost. This was fun. I think this was my first my first build live. I enjoyed it. Everything worked, so you know, it's a bonus. Thank you very much for sticking around. Can discuss the my little riddle and on Slack or wherever, and I'll plug the Boldport Club. It's a club where you get a monthly kit to your door, and we really try to make it interesting. Interesting circuits that or interesting looking circuits that will challenge you, hopefully, or interest you or intrigue you, or give you an hour of an interesting time with your soldering iron, and a result that you might be able to put on the shelf and show people. But the strongest point of the club is the community. Very lively community on Slack. We have a private Slack and very supportive community. I can say that because they support me, firstly by paying, which is great, allowing me to continue doing this work. But they also support by doing things for the club, which is amazing. It's really nice. But I mean, while we're on the topic of support, I think when things go wrong, the community is so nice about things. So I get people telling me that I forgot to put that you know, the it was shipped without something. We had cases where it was shipped without the PCB, which is terrible. Um, but it happens when you're building hundreds of kits every month, and we're trying to minimize that it won't happen again. They're almost apologetic, you know, when I complain, and I was like, it's so nice because I know that they're sympathetic, and so to me the community is also quite supportive, and it's quite nice. So thank you, whoever is watching. Anyway, all right, bye.